Come back. So this is problem 6, section 1.6. Evaluate the limit h approaching 0, square root h plus 9 minus 9 over h. If the limit does not exist, enter f. Now this is a strange kind of question. You will see in a minute why. So the question is square limit h approaching 0, square root of h plus 9 minus 9 over h. So when I actually plug in 0, I get square root 9, which is a 3, minus 9 over 0. Okay? So what is this? It is not the same as 0 over 0. Okay? It is some number over 0. It is therefore some kind of infinity. All right? So what do I mean by that? Let us graph this and see. All right. So I'm going to use x instead of h because this one requires me to. So there is a numerator and a denominator. So I'll separate that out. So wherever I see h, I'll place an x. Okay. And numerator is square root x plus 9 minus 9. All right. So you see how this looks like. This is what I mean. When x goes to 0, I go to negative infinity from the right and positive infinity from the left. You see? And so this limit is some kind of infinity, but they are two different kinds of infinities. So this does not exist. All right. So if limit doesn't exist, I should plug in f. All right. So which is correct? Next question. Limit x approaching 9 of 1 by square root x minus 3 minus 6 over x minus 9. Now this one, if you plug in x equals 9, you get 3 minus 3, 0. 9 minus 9, 0. So some kind of infinity minus some kind of infinity. This requires some work. Okay. So let's look at that. X approaching 9 of this fraction minus this fraction. Notice this might seem unusual, but over time you will get used to it. Square root x minus 3 is actually a factor of x minus 9. See, if I'm allowed square root x, notice what is x minus 9? X minus 9 is by difference, you can think of it as square root x squared minus 3 squared. So by difference of squares, this is nothing but square root x plus 3 and square root x minus 3. So there is a factorization here going on. So x minus 9 is square root x squared minus 3 squared, and that's a difference of squares. So it is root x plus 3, root x minus 3. Why do I do this? Look, there is a root x minus 3. All right. So that gives me a hint that I need to factor this. So I took this, factored it. Okay. Everything else is as it is. Now, I need common denominator because this is a difference, a subtraction of fractions. So this fraction, to get the common denominator, I need one more factor. So I write that in the denominator, whatever I write in the denominator, I write to the numerator. So that fraction is same as this fraction minus the same thing repeated. Now that I have common factors, I write like that. Root x plus 3 minus 6. So I have combined the numerators. Plus 3 minus 6 is a minus 3. Everything else is the same. Now notice root x minus 3 is a common factor. So I can cancel these two as long as root x minus 3 is not 0. But x is approaching 9. X is not equal 9. So I can safely cancel these two. I'm therefore left with 1 over root x plus 3. Now if I plug in x equals 9, I get 1 over root 9 plus 3. 1 over 3 plus 3, which is 1 over 6. All right, next one. Cotangent 6x over cosecant 6x as x approaches 0. Well, first thing you can check is when you plug in 0, cotan at 0 is undefined. Cosecant at 0 is undefined. So this is undefined to begin with. So we don't plug 0. Instead, we try to rewrite it. Cotan is 1 over tan. Cosecant is 1 over sine. So I've rewritten my expression 1 over tan 6x over 1 over sine 6x. A fraction divided by a fraction. How do I divide by a fraction? Multiply by the reciprocal of this guy. You see? So that gives me 1 over tan 6x times sine 6x over 1. So I'm taking limit as x approaches 0 of this entire expression. So now this gives me, remember our sine and tan laws, whatever is inside, if it's going to 0, I must have that same quantity dividing it. So notice this is already in the denominator. So if I divide by 6x, 6x is upstairs. Divide this by 6x. Did I change my expression? No, because 6x above, 6x below, the expression is same. Okay, there is no change in my formula because in my expression there is 6x above, 6x below. Okay, but fortunately this limit now approaches 1 and this limit approaches 1. Why? The object inside goes to 0 and the same thing divides it. Likewise for the tan part. The object inside goes to 0 and the same thing is dividing it. Okay, so answer is 1. Next. Limit x approaching 1, x squared minus 3x plus 2 over x cubed minus 1. An expression like this, first try substitute x equals 1. When you plug in x equals 1, you get 1 minus 1, 0 in the bottom. 1 minus 3 plus 2, 0 in the top, 0 over 0. So you know you need to simplify this somehow. Fortunately, this is an easy one. Numerator factors. Okay, x minus 2, x plus 1. That's the factorization of the numerator. Denominator also factors. If you remember, we saw some such expressions. X minus 1 and whatever is left over, the highest degree needed is x squared, and then you go down. Now, x is approaching 1, x is not equal to 1. So, x minus 1 cancel. You are left with these two. Now plug in x equals 1. You get 1 minus 2 above and 1 plus 1 plus 1 below. So negative 1/3. Okay. Next problem. Evaluate this particular limit. Okay. Let's write this down separately. You will notice x is approaching 0. But there is also an h. So what happens then is you have to think of h as some number, say 5 or some such thing. All right. Now this one is straightforward. You set x to 0. If you set x to 0, you get 8h squared minus, well, that goes away, over h. That is 8h squared over h. Simplifying, you get 8h. So I didn't have to do anything, just plug in x equals 0. I get 8 times h. All right, next problem we'll start on the next video. Okay, until then.